My name's Thomas Kraus. I'm from VMware's Cloud Native Apps business unit.
Yep. Merlin Glynn. I'm also in the VMware CNA BU, like we like to acronym it. And I'm a product manager, and I'm a product manager for our Pivotal container service product that we're jointly delivering with Pivotal. So that's why I'm here, kind of do some PKS stuff.
So Merlin came up with the idea of doing a session on PKS probably a month and a half ago. And we decided, instead of just giving you a product pitch and going through a bunch of slides about the individual components that make up PKS and some of the associated technologies, we would try and build a real-world app and maybe go through a real-world scenario of how you could leverage PKS.
I don't know if I call your app real-world.
No, it's not real-world. It is an app, though. Technically, it's an app.
It's an app.
So that's what we did. We basically built a simple app. We're going to try and keep this relatively short as far as some of the foundational knowledge that maybe will help you make sense of the stuff you're going to see at the end, which is the demo. We're going to try an interactive demo. Merlin's very brave, so he's going to give that a shot. So you can say, I was here when those guys at the Spring One conference tried to do a live demo, and it blew up in everyone's face. Yeah. You guys were here. We are going to be talking briefly about some product that is not released yet. So I'm mandated to kind of show you this really quickly. Just give you a little context as to what PKS is. How many people here have heard of PKS, I would imagine, at a Spring conference? Yeah, awesome.
Awesome.
PKS is, I'm going to go through just a high level of what it is. Merlin's going to go into a slightly deeper dive. I'll talk about some of the components, and then we'll do the demo. From a goals perspective, I guess you could say PKS is intended to deliver production-grade Kubernetes clusters to the enterprise in a simple-to-deploy manner, but even more importantly than that, a simple-to-operate manner. I've done a lot of container deployments and container orchestration deployments using Mesos, using Kubernetes in a previous life before I got to VMware. And standing these things up can sometimes be challenging, whether using open source components or enterprise software. But it's not impossible. The real challenge is really operating these things, updating the underlying platform code, scaling out Kubernetes worker nodes, recovering from failure of an etcd node. Those types of things are somewhat, you can really cut your teeth and have issues as an operations team when you're trying to operate Kubernetes at scale in production. And so some of these things that will give you that kind of, I'm sorry, I'm not even on the right slide. Some of the elements that would kind of give you this, Merlin's going to talk about the control plane, some of the day 2 activities, but the ability to let a developer spin up his own Kubernetes cluster to do with what he wants, and then the RBAC and authorization and authentication controls to allow him to securely access that. Merlin's going to talk about Bosch, but underneath this technology, and one of the differentiators is NSXT. Think of NSXT as kind of providing the same types of capabilities that a Flannel would or a Calico, but it's got a lot more advantages of dynamically provisioning isolated networks on demand to isolate, let's say, a Kubernetes namespace, spin up a load balancer on demand to provide ingress into your Kubernetes application. And there's a session later today for something by the NSX team at VMware on a little more deeper dive into the NSXT integrations with PKS.
Yes, aside from VMware and Usha from Pivotal, it's going to be a really good session to dig into, what is an SDN and what is CNI and how does it actually work with Kubernetes. It's going to be a really good deep dive for them.
Yep. And then I'm going to spend some time in a couple slides just quickly going over what Harbor is, why it's relevant to you guys in the context of PKS or any Kubernetes deployment, why you would want an enterprise-grade container registry, some of the capabilities that Harbor provides that differentiates it from some of the other open source and enterprise offerings out there for a Docker registry. So yeah, that's about it. I'm going to let Merlin go into some details.
Yeah.
Take it away, big guy.
Yeah, we are going to do a demo. We're just kind of trying to set up the demo here. So one of the things you're going to see, and the demo is going to be me in a live environment, so I'm going to go ahead and apologize ahead of time that I type like a wounded chicken, and sometimes I do and say stupid things, and I may fail, but hey, people already know that I'm an idiot, so it doesn't matter. So this is a technical overview of what PKS is, and we're going to start with PKS before we get into our pipeline, because if you guys saw the label outside, it's all about building pipelines that we want to focus on some of the benefits of Harbor. But first, we're going to start up as a developer that wants PKS. And so if you look at this visual, it looks like a lot of stuff going on. But one of the key things I'll point out, because I don't have my laser pointer, is application teams on the right, like teams A and teams B. Really what we're trying to do with PKS at its heart is give the operator or the platform reliability engineer, the guy in green all the way to the left who has all these day one and day two needs, the ability to have some kind of level of control for compliance and security and all sorts of other reasons. So he has the ability to maintain some level of control from an enterprise production perspective, but also gives us developers the ability to do the self-service consumption model of Kubernetes. So we're actually going to see that in the demo where I'm going to play the role of the application DevOps owner, the blue guy over there, and make a call to this API on the PKS control plane and just get a dynamically provisioned Kubernetes cluster. So it doesn't stop there, so to speak, with PKS. It's not just day one provision in the cluster, but also keeping these clusters production grade, keeping them healthy. So when we have something like a master etcd node fail in a cluster, we'll have BOSH in the back end. And just by show of hands, so I know how much time to spend on this, how many of you guys actually run production, either Cloud Foundry or any other release with BOSH today? All right, so maybe about a good third of you. So maybe I should spend a little time on this. I know I don't have to spend it for you because like you're Mr. BOSH now. Anyway, so what BOSH is doing for us, it has these agents and it tracks whenever something fails and recovers for us. So it gives us some good day two auto rebuild capabilities. In addition, it gives us a metaphor to abstract how we want to scale things. You know, how do we want to put our clusters either larger by adding worker nodes for our Kubernetes clusters or just scaling out to multiple clusters, as you can see in the visual here. So we have an easy metaphor, an easy API-driven way that the application DevOps owner can request that stuff. Also, what about patching and upgrades? You know, can I upgrade my Kubernetes clusters from 1.7 to 1.8 to 1.9 to keep in step with mainstream K8s deployments? That's another goal of PKS that we're going to give the ability for the PRE, the green guy over there, to say, hey, I've got these updates available, and then have the blue guy be able to say, all right, I want to update I want to do a blue-green deployment, or I want to update live my Kubernetes clusters from a given Kubernetes release to another. So those are some of the targeted day two type things. And then we also have the ability for BOSH to and PKS, the control plane, to kind of log all these activities so we know who's doing what from a development perspective. So we'll see a little bit of that in the demo. You know, I don't want to talk about the slideware too much because I'm going to hand off to Tom now. The star of this demo, though, isn't actually going to be PKS proper, which is the whole API-driven stuff we just looked at. But the star of this demo is going to be, hey, what do you actually do with these Kubernetes clusters? And like, how do you keep images clean and, stay away from nasty CVEs?
Yeah, so I've been involved in a couple different kind of large-scale container orchestration projects, and one of the often overlooked elements is the registry. It's kind of an assumed thing. We'll just stand up a Docker registry, or we'll stand up vendor A's registry. And what ends up happening is the JIRA tickets start to pile up because it's not configured correctly, replication isn't there. Customer had an idea of building a curated list of images or a curated repository of images, and it's very difficult to do. I guess you could say one of the high-level project goals of Harbor is to actually achieve that. So take a simple Docker registry, wrap it with some enterprise authentication and authorization, LDAP integration, replication, Clair capabilities for CVE scanning, and then image signing capabilities. So kind of take the simple nature of a Docker registry, but give you the capabilities to actually operate it securely inside the enterprise.
Is Harbor part of PKS?
Good question.
It is. Yeah.
So Harbor is part of PKS. It's also an open source project. Thanks for the cue there. Mm-hmm. It's also an open source project that you can download on your own from VMware and throw it into any, it works with any type of Docker image system that would require a Docker image. But PKS will deploy it. It will integrate the certs with your Kubernetes worker nodes and kind of integrate it into the overall PKS solution.
And for a few Pivotal Operations Manager customers, we're going to have a tile up on PivNet probably within the next 5 to 10 days, because Harbor's also able to be leveraged for your ERT deployments to be able to pull, whitelist and pull Docker images there. But it's going to be tightly integrated with PKS, so we have automatic trust with certificates and the future authentication, blah, blah, blah. Let's go. Yes, Clair is going to be included with Harbor. Yeah. Part of the tile, part of the release, and Notary.
So we thought we'd show you Harbor really quickly, just from the illustration of like a CI/CD pipeline. Perhaps you have a developer that's starting to build an application. He wants to run it inside Docker or Kubernetes as a Docker image. Maybe he pulls down a base image, and this is kind of the gist of the overall demo that you're going to see. Maybe it's an Alpine image, maybe it's a Golang image, an official Golang image because it's a Go app. He can push that into Harbor. He can scan that with Clair, which is built in with or bundled with Harbor and pre-configured for Harbor. And then he can, depending on the results of that scan, and we're going to show you this in the demo, sign that image so that it can be pulled into the rest of the Kubernetes nodes. And those elements are kind of all built in together. So you can see the Clair icon and the Notary icon. They're all deployed as one. There's a reverse proxy in front of them to make it kind of enterprise grade. And then you can actually replicate your Harbor images. That's another often overlooked element to a registry. If you're going to put these images somewhere, a lot of these other solutions will have like just an S3 backend and rely on the storage to do the replication. Replication is actually built into Harbor. Any questions on this before I move on? Move on. All right. And then from a Clair perspective for CVE scanning, this is a screenshot, but Clair is a relatively simple but very important product. I think it was originally developed by CoreOS and then open sourced. You have on the left CVE data sources, so you have typical OS data CVE bug trackers and locations to pull CVE information, and then you have the NIST National Vulnerability Database. All that's pulled in, stored in Postgres. You have the Harbor backend, which is your actual Docker registry. That's storing your images in projects. Within those projects are individual repos. And then within those repos, you know, the Docker layered file system has various layers that have been committed into that registry. Clair will scan those layers individually, look at the file system components, and cross-reference that with the CVE data sources that are in the database and tell you how many critical, high, medium, and low vulnerabilities are actually in the image that you just uploaded. All that's built in and open sourced. Sorry. So the image, I don't know if that's configurable today. Yeah.
It could be the tile, now I'm getting the product specifics. At initial release, it's going to be using a local. So you'd be putting a persistent disk being managed by Bosch. But in the next release, we're going to support config of the external. The OSS code supports it to external S3 compliant storage too. So you could do either or. Just crawl before you walk with the tile kind of thing.
That structure can be configured to be offline as well, or do you have to have online access to all those different repos to be able to do them?
There's an offline way today. It's ugly. It's basically a Postgres dump into from a Clair instance that has internet access, and then a restore to a Clair instance that doesn't have. So it's very hacky.
Is the backlog though? Does it have it in there to be able to configure for offline use?
You're talking about the CVE database, or you're talking about the images? Yeah. Yeah, the CVE database can be going through this, we can hit that after, Keith, but yeah, the CVE database can be configured to not pull daily so that you're pushing it in manually.
And then the last piece, I think before we get into the solution that we built and put together, is just the content trust. So this is basically allowing you to confirm the identity of a person that pushes a Docker image into your registry and then control what images are allowed to be pulled or pushed from that registry. So you would digitally sign an image when you initially push it. That signature would follow it into the Notary database, and then you could determine whether or not you wanted to allow unsigned images to be pulled. In the context of the solution that we kind of put together, we're going to determine through automation, I don't want to steal your thunder, but through automation, we're going to determine whether a threshold has been exceeded with CVEs, and if it has not, we will sign the image so that all of our worker nodes can pull that image down. Because we've configured Docker Trusted Registry, Docker Content Trust, in the cluster, they will not pull down unsigned images. So it kind of works. So it's just a way to give your developers the freedom to push these images, develop them, push them up to Harbor, but they can't be distributed throughout the enterprise until you've actually signed them and determined that you feel that they're ready to be allowed to get into the distributed and run on top of Kubernetes. All right, so then let's get into really quickly the solution. Just a high-level overview. So we have a developer on the left. Again, he's building a conference web app, a very simple app, as Merlin alluded to. It's a Go application. He's on his laptop. Maybe he's on a VDI desktop. He writes some code. He commits it to Git stash internally. In the middle here, you see concourse. And one of the lessons we learned throughout this process is concourse is really the glue that kind of holds this all together. And substitute your CI/CD pipeline or CI/CD product for concourse in this model. But we used concourse. It was great for what we needed it to do. For the most part, I think you added one data or resource type.
Yeah,
but for the most part.
Yeah, I'll go over that when I hit the pipeline.
Yep.
Did a little bit of custom work, but
yep.
It's all shareable, so on GitHub. And it's, since I did it, it's not all that great.
So part of that pipeline that Merlin wrote is going to have a webhook trigger that's talking to our repo on Git stash. It's actually on GitHub, and we'll monitor it for any new commits or new pushes. When it detects a new push to the application, it's going to check out the source code. Within that source code is a Docker file within the project, within that repo. And that Docker file basically specifies a base image to pull down to both build and run the application on our Kubernetes cluster. And then it actually has any dependencies that are required. The Docker file that's going to be pulled down and needed initially for the build process is an official Golang image. And we'll see that in the actual demo. So we'll pull that base image, that Golang Alpine or Golang Ubuntu image. When we do the Git checkout on the concourse worker node, the Docker file will tell the concourse worker node to actually copy the source code into the image. Inside that image is inside that official Golang image is some scripts to help you compile Go programs. It'll compile the program, download the dependencies inside the image, and then it will set a default executable. So when we start that application in Kubernetes, it's going to start the web server and serve up the static web files that we've developed for it. And then once the worker node does that, it basically goes through the build process, tags the image for Harbor, and then does a Docker push to push back up to the Harbor registry. Once the image is up there, the pipeline will then do a Clair scan and look for CVE vulnerabilities within that image that we just pushed. And depending on the results of that, it will either sign or the pipeline will fail. And if it doesn't sign the image, it can't be pulled.
So those results are fed back to Concourse for an ultimate pipeline?
We could. This pipeline is a very simple, just reference pipeline. And so all we're doing is we're just sensing, we're actually string regexing the output of the Clair scan and grabbing the variable for the integer, right, of like high vulnerabilities and just stopping the pipeline. But we could take that a step further and take this, like poll for the CVE database and like what are the actual CVEs that it failed on, and then forward that to either another pipeline or another person to take action on. But what you're going to see, I built it, so it's like simple.
And then the concourse pipeline is going to run a kubectl command. It'll bind to the cluster, run a kubectl command, develop a YAML file, and actually tell Kubernetes to actually run that application. And when it tells it to run that application, part of that pod spec is actually calling for its image from Harbor, and the image is pulled down. So enough slideware.
Demo. See if I could do this in 10 minutes or less. And
is that what we have left?
Not look like an idiot. All right. Hopefully the desktop will pop up here. Awesome. There's our slides. So first thing we're going to start off with, if I can get to my right desktop, is we'll do a little bit of that PKS demo. So I have an operations manager deployed here that I'm going to head up to. Look at our ops man, and hey, I'm already logged in. I must have been in here earlier. So the first point that I'm going to stress out in the demo is that this has all been deployed by ops manager, and so even though some of you guys may not have actually seen PKS or seen Harbor, when I say these things are imminently going to be on PivNet, I mean they're imminently going to be on PivNet. So you'll be able to get access to them very soon. But these are pre-release builds, so some of the stuff you're going to see, like when we're doing the CLI, might differ whenever you actually get the real product. But we've got Harbor deployed and we've got PKS deployed. So part of PKS, we're talking about requesting, the developer requesting his Kubernetes cluster, his or her Kubernetes cluster to start off with. We have this thing called the OD broker, or the on-demand broker, which has been labeled as the Pivotal Container Service. So that's running as an instance that I've got an IP endpoint. And that's one of the things I'm going to give to a developer to be able to request a cluster. So that developer is going to have already the endpoint and a credential that I've given them inside of the PKS environment to get a cluster. So it should be as simple as just hitting a REST API. So I've got a mocked up CLI that I'm the developer that have been granted access. And I'm going to go ahead and take a list and take a look at what Kubernetes clusters they already have running in the environment. And you can see I've already got one Kubernetes cluster running. That's the Spring One demo cluster. That's the one we're going to push our pipeline to. The reason being is because when I'm going to initiate creating a cluster, I don't want to wait 12 minutes and watch a BOSH task go up. You know, I'm sure you guys don't want to do that either. But at least to demonstrate how easy it is going to be, PKS is going to be for a developer to consume a production-grade Kubernetes. It's as simple as them issuing a CLI command with a -- create. And again, remember, the CLI may be different when we put this GA. This is just a mock-up CLI. And I could just put Merlin, for the name of my cluster here. And so what should come back is I'm communicating with that PKS API, and I could give it expansive JSON and say, hey, I want some different options. Like I might want to put some things like the number of worker nodes or some other configuration data on the Kubernetes cluster that I'm requesting. Or I could just go with the default plan, which is what I'm doing here. And we can see that I get this status back that it's creating. And if I did like another PKS list, I can see, hey, there's this cluster Merlin in progress. Now, right now, I'm the blue guy in that image earlier. Like I'm the DevOps guy. If I was the operator, I could probably do something like this bosh-c and just take a look at my task. And I can see, he says, unless I just did it too quickly, either that or we're having poor connectivity, I should see that bosh task processing. There we go, preparing to do deployment. So this is the actual BOSH task. In the back end, what's happened is PKS is this thing called the service adapter that's generated my deployment manifest dynamically and is handing that off to BOSH to manage the deployment and give me a nice shiny new Kubernetes cluster. So I'm not going to make you guys wait. Like I said, this deployment's probably 6 or 7 minutes. I was fibbing if I said 10, but I'm not going to make you wait 6 or 7 minutes because remember, we already have a cluster that's deployed called Spring One Demo. So I'm going to go ahead and bind, which is another primitive that we're going to have on the PKS API. I'm going to go ahead and bind to that cluster. And what that's going to do is it's going to download the cert and the token and credentials that I need to be able to interact with the Kubernetes API. And what I've mocked up in the CLI is actually putting that into my kube config. So I could literally, after I've grabbed my credentials and bound to the cluster, I could just do a get all and see there's my Kubernetes API that I'm interacting with. And I can see that I've got nothing running there. So now when I get to the pipeline part, I want to get something running there. So
awesome Go app.
Yeah, this awesome Go app. So let's see. I think I've got a little Spring one. Yeah. And I think we got our little Go app here, right? So if I take a look, I've got a Docker file. Remember I told you I type like a wounded chicken, so you guys are going to have to put up with it. I've got a Docker file here that's already committed to my Go app repo of how I'm actually building my Go app, or actually how Tom's building it because he's the developer. And I'm just the operator, stupid operator guy. So we can see that's our Docker file. Now what we want to do is actually have a pipeline execute on pulling this repo with the Docker file and do all that nice scanning stuff that we just talked about. So I've got a pipeline, if Merlin can remember his. There he goes. And these repos we're going to have like on the last slide of the deck, and probably as posted, you guys can hit some of these repos public. You may or not want to, because like I said, I'm an idiot sometimes. What I do isn't all that great. But we're going to go ahead and do a set pipeline, which is going to, I'm kind of speeding things along. I've got if you guys are familiar with concourse, I'm going to go ahead and interact with a concourse instance that I've already got pre-deployed. I've got a defined YAML file that says what I want the pipeline to do. That's what that -c flag is for, which is inside of this repo. And then I've got another little file, that -l, that has a params YAML. That's got some of my stuff like my token for my cluster. Like that cluster that I just created, the Spring One demo cluster for Kubernetes, I've taken the cert and the token and I've kind of passed them as input parameters to my pipeline. So when I run this, this is concourse coming back to me and saying, hey, is this what you want to have happen in your pipeline? And yeah, it is. And one of the things I want to have happen is I want to push this image as part of the pipeline build. So I'm going to go ahead and say yes. There's my pipeline. And now let me go ahead and actually get to a visual of that pipeline. I could do that here. So if I do refresh, there's our pipeline, right? And it won't let me see the whole pipeline. There we go. Boy, my two-finger movements are bad on this new trackpad. So we've got 3 main stages. We've got build a Docker image job, we've got scan the Docker image, and sign the Docker image. So I'm going to go ahead and start the pipeline. Oh, wow, that worked even better than I hoped. Come on. Let me just reload it. My finger gestures, if you guys saw the finger gestures I'm doing there, they're not working. All right, so let me go ahead and start the pipeline, because whenever I instantiate a new pipeline, it's going to be paused. So the first thing that's going to happen is that it's set to auto-trigger off of the git go HTTP resource type. So that's the Git repo that you just saw me look at the Docker file on. That stuff's already pushed and committed to Git. And since I've just instantiated the pipeline, it's going to go ahead and sense that there's something it needs to execute on. So it's going to go ahead and start building the Docker image. Now this is using a built-in concourse type. So if you guys are familiar with, raise your hand if you've used concourse before. All right, so more people have used concourse than are using Bosh. That just sounds weird. But OK, so this is a built-in resource type that anyone can use. And what it's actually doing is kind of interesting. It's, since we're building an image, like we're pulling the Docker file and building it, it's actually running, it's not Docker in Docker, because it's more like Docker in Garden C, because Garden is actually what's running in the back end of our concourse instance to manage containers. But we're having to run this container like in a privileged mode so that it can interact with C groups and mount some kind of a volume system so that it can build an image locally in its local repository before it can push it up to our Harbor instance. So while this Docker image is building, we can kind of look over here to Harbor, where I've already logged in. And we can see that we have projects in Harbor, which projects are kind of analogous to a tenancy inside of Harbor. And so we've got the library project, where if you guys are paying attention to what I looked at in the concourse pipeline, that's where we want our Spring One demo app to push. So if we take a look at it right now, we just have that Nginx and mag image that's sitting in the repository. So we'll come back here and take a look at that Docker image. And it's already built our Docker image and pushed it. And because we're going to do something else with the Docker image, we're going to take it and move it to another stage in the pipeline. It's actually going to pull it back down. God, this resolution's killing me, which is what it's doing right now. So it's going to go ahead and pull it back down. Now, in our pipeline, in this demo pipeline, what we're doing is we're taking that image and we're pushing it back up to our Docker registry and initiating the Clair scan from that Docker registry location, the Harbor location, which you probably want to do in a production pipeline if you're doing this. This is where I said I'm an idiot sometimes and I don't do things the right way. In production, you probably want to scan your image before you even pushed it into your Docker registry. Because the next thing we're going to do is sign it. We're going to notarize it. We're going to sign that it's coming from a trusted author or trusted content. If you're doing that before it even gets into the registry, that way you can actually sign it as you're pushing it up in its first instance. And you don't have to deal with whether you've got your registry set to disallow non-signed pulls, which is what would be happening in our step here. I digress. So we built our Docker image, come back to Harbor, and we take a look. And if we do like a little refresh, voila, there's our Spring One demo image, and we can take a look at it and see Harbor tells us, hey, it's not scanned yet, and it's not signed. So let's go back to our pipeline, and it's executing on actually scanning. Now, this is not using an embedded resource type inside a concourse. This is a custom job. It's a Snowflake job. It'd probably be nice if I took the time and actually made a Clair resource type. But this is just doing a little bit of bash foo, and it's using a tool called Clair Control. And so what you're going to see that our job do is it's actually going to be pulling our base Ubuntu image, because that's the image the job's going to run on, and it's going to do a little bit of installation because I was lazy. I didn't even pack the Clair command into the worker image. So I'm actually dynamically building the worker image right now. And the next thing we're going to see after it actually gets the Clair dependencies down and start running is now we see it's actually going to start scanning layers. And that's kind of how Clair works. It'll scan layers and compare layer composition so it can reuse some of its scanned metadata and give us a composite report of the collection's CVE vulnerabilities. So as we run to the end here, we can see that we got a failed job. And if we look why, we can see that our Clair report is saying, hey, you have 53 53 high assessment CVEs based on our CVE database. And so the pipeline just stops. It doesn't even sign the image. It doesn't even do anything else with the image. And this is where we could perform other actions like, well, based on this failure condition, what do we do? Which is actually a question I'll pose here to the group to think about. What do you do whenever you have a Docker image that has failed a vulnerability assessment? I mean, in this case, we're scanning it at build time, so we have the luxury of being able to go back and repair it and find out what those CVEs are, which we're going to do here in a second. But what happens when you have hundreds of these things in production and you start running scans post-creation and you're finding that you have high levels of vulnerabilities? How do you address those things? And there's some interesting questions to think about. We can talk as we go. Anyway, we can see here that we've got our pipeline has failed. It has not gone forward to even deploying our application in Kubernetes. It has said, hey, you got something wrong with your image. You got some vulnerabilities there. So I can come back as the developer and take a look at my Docker file. And we made this pretty simple for like a demo perspective. We just had like a really old version of Golang, and we'll go ahead and fix it. Oh. Man, these new Macs with the escape keys drive me crazy.
Got an extra letter in there.
Do I?
Gert commit.
I told you guys I type like a wounded chicken. I'm not the world's best live demonstrator. Awesome. Let's go ahead and push this. And what should happen now, after we get a clean push, is we come back here and see our pipeline execute again. And so now that I've done a commit, it's, this is concourse. Concourse, I guess this is tunable, but concourse usually takes on the order of, like you have check windows, and we left ours default, so it takes in the order of like a minute or two to sense the commit. Now we're going to go ahead and rebuild the whole process again. We're going to go ahead and rebuild the Docker image, and we're going to scan it again. And this time, because we're using a newer Golang that has a smaller, it's just not that it's better, it's just that the vulnerabilities haven't been found in it yet. But it's got a lower threshold of vulnerabilities, and we should have it go through and run through the image signing process and be able to put it as a trusted content. So, how many minutes do we have left here? While this is running, we could probably take some questions, right?
Sure, yeah.
Because this will take 4 to 5 minutes to run.
Yep.
So I'll open the floor to questions as we watch the concourse magic.
Most of those vulnerabilities were introduced from the base image that we're building our app off of. Not most of them, all of them. The Go app itself is just using the net HTTP module. It's very simple. So those are all coming from the Alpine. The lack of vulnerabilities comes from Alpine. The vulnerabilities we found came from Jesse, an old Ubuntu version. Sorry, go ahead. I'm sorry?
Oh. Harbor? Oh, PKS. Okay, so PKS is going to be, I'm trying to look for the right word in my PM head for this. Early access program, meaning we're going to have select customers that are going to be getting availability of it this month. General availability is going to be in the Q1 timeframe, probably mid-Q1. I can't be any more specific than that, but it's imminent. As you can see, the code is functional, and we're really trying to get down to testing and support structure and all that stuff before we can release it generally. Does that answer the question? Now, if you look here, this is our pipeline running again, and it's already run through the. Let me scroll down. It's already run through and said, "Hey, this new image that you've given me, I've run it through my scan and everything's clean. So let me go ahead and go on to the next steps inside of our pipeline." And the next steps inside of our pipeline are to sign the image. And this is kind of a tricky process because, I'm running this in a concourse pipeline. When you sign an image, you really want to have like a trusted root key for your collection, and you want it to make sure that you're ensuring that it's coming from a trusted source, which means you have these keys that are dynamically generated, but they're like one-time only keys that you really have to keep safe and store externally. Our pipeline, we're not really doing that intelligently. We're just passing it as an input parameter, but you might want to have something like keeping it in Vault and pulling and pushing them out of Vault as you iterate and sign newer editions of this image. Now, the way our pipeline is set up is after everything happens, after the image is signed, we want to go ahead and deploy an image to that Kubernetes cluster that we requested earlier. Now, this goes back to another resource type. So we created a custom Kubernetes resource type in Concourse so we could do things like deployments and service pushes. And the repo for the one that because I did it is very simple. The repo's there, so you guys take a look at it if you want to run pushing Kubernetes apps in your concourse instance. But we could see that our app and service have been pushed and marked online. So I can come back here now to my Kubernetes cluster, and if I do like a kubectl get all, I should now see, instead of just, just the API endpoint, I've now got this service and this Go HTTP app that's been published. And let's go ahead and get nodes, just so we can get an IP address. We didn't really want to, because we only had limited time, we didn't really want to go into like the whole thing of ingress controllers and NSXT integration. So this is just using a simple node port service to expose the application. But we can see this is our worker node from our cluster, and it's listening on port 3001. And so I can come back here, and let's just, that's me. No, it's not. And this is port 3001. And, whoa, it's not HTTPS, Merlin. Yeah. See, I'm telling you guys, I tap like a wounded chicken. I think this is right for the port. See, I was right. See, Keith?
Ooh, wow.
You're always slamming me, Keith, but sometimes I'm right. And so this is our app, So I guess back to the key thing of what we're trying to demonstrate here is, with PKS, we're giving you guys, or we're giving customers the ability to have production-grade Kubernetes as a service, not like a multi-tenant construct of a single Kubernetes cluster, being able to iterate them quickly, simply, and with production-grade capabilities. But then it's not just the Kubernetes. What do you do with the applications that you're running on there? What kind of service mesh do you need, where we have the GCP service broker coming into the play and things we can do with Istio or Linkerd? And also, how do you make sure, the real problem that we're trying to key on is how you make sure the applications that you're targeting for this type of a world, this type of a container-based landscape, how do you make sure they're secure? And so that's why we're including Harbor. I'd mentioned PKS earlier. Harbor is going to be available in the same December timeframe, and actually, Harbor as a standalone tile, back to your question earlier, is going to be available before PKS is even generally available, because we want to be able to leverage it with the ERT as well. But it's going to have some integration with PKS, which is what you just saw is it automatically trusts right now, like all the certs are automatically there to trust. But Harbor, you should be able to get that quicker. And with Harbor, we're trying to show you that when you get in this container space, in this container world, you really have to look at how do we build policy and automation around image building. Because it's going to be a really important topic as you begin to scale these out. How are these images clean? How are they safe? How are they built? How can you repeat and repair these things when you do find that there's problems? And that's, this is the first tool. It doesn't answer everything, but this is the first tool we're throwing out there to at least let you know when and where the problems are. So I will stop. And are there any other questions? Yeah.
So if an organization has already invested in something like Docker EE, which comes with its own notary and registry, are they complementary and they work together?
So this is the same. This is actually the same implementation of notary. So it could be used in the same manner. It's just a different notary endpoint and signing endpoint. So. They just need to share the same trust, cert issuers. Right. The same cert issuers or same delegates to it. Yeah. So you could do that.
Thank you.
Yeah. All right.
You mentioned robust access control. Is that independent of all of the CF infrastructure? Is it robust access control, or is it integrated?
Robust access to Harbor or to PKS? To Harbor. It's not going to be integrated in initial release, but in the future, like a post 1.0 world, it will be integrated at that layer, so that you'd have a common authentication endpoint, and that you would have a certain quota granted to you in PKS, and then also a certain project and role granted to you, from the same credential in the project. In Harbor. And we're also looking at a service, like a service broker, so that you can dynamically request projects and get a certain role into it through a Kubernetes catalog. Open source. We're packaging them up as a tile and providing them with PKS. Like, in other words, when you go to download PKS, it'll be part of the allowable download bundles, but you could also download it separately because you could use it with ERT. But it's all open source.
And even the components within Harbor are all open source. So it's nothing but an Nginx controller in front of a Docker v2 compliant registry, in front of Notary, in front of Clair, and then bundling it all together and making it kind of enterprise ready. Yeah.
Harbor's Bosch release is in a Git repo, and I want to say it's public. I should know this since I'm like a PM on it, but
yeah,
No, they're not published in the community on Bosch.io, but the Git repo's there. As soon as the tile's online, though, like that's part of bringing it all online. That's the core piece, and that'll be in the community on Bosch.io. Well, the integration that I talked about with trusted certificates, which is the 1.0 timeframe, I say integrated with PKS. It's actually integrated with Kubo in the effect that the trusted CA cert is being packed in by Bosch to all of the worker nodes, so that whenever in a PKS world, as you've configured it through Opsman, it's just simply a kubectl run, and you're given the image location. You don't have to deal with any trust authorities. You would have to do like your Docker, your credential. Like the developer would have to get a credential to Harbor and put that as a Docker Edge secret, but you wouldn't have to mess with certificates. All right. If there are no other questions, I see we've cleared half of the room.
Excellent. Thanks.